what electricity really is. Let's talk about electricity. You probably think you understand it. After all, you live surrounded by it. Right now, charge is moving through the device in front of you. Electricity is lighting your room, preserving your food, powering your screens. It's everywhere, so surely you know what it is. All right then? All right then. Explain it. What actually happens the moment you plug something in? Where does that power truly originate? What is electricity at its deepest level? Most people give answers that sound confident but say very little. They call it energy. They say it's electrons flowing. They describe it as current inside a wire. But notice something about those explanations. They don't really explain anything. They just give the mystery a new name. Yes, electrons move, but why do they move? What force pushes them? And how does that push become heat, light, motion, reality? Here's the unsettling truth. Electricity is far stranger than we're taught to believe. We present it as ordinary, predictable, safe. We smooth over its weirdness until it feels boring. But the moment you actually look at what's happening, the moment you pull back the curtain, you realize we are manipulating something extraordinary, something that completely overturns how you think the world works. Let me show you. A simple experiment. Take a piece of plastic wrap, pull off a strip, rub it quickly between your hands like you're trying to warm them. Now bring it close to the back of your hand. Don't touch. Watch your arm hairs rise. Feel them lean toward the plastic. Pause for a second. You rubbed plastic. No batteries, no wires, no power source, just friction. And yet that plastic is pulling on your body across empty space. How is that possible? In everyday life, pushing and pulling require contact. You move a chair by touching it. You lift a book by touching it. Force seems to demand contact. And yet here is plastic, not touching you, exerting a force through nothing. Most people shrug. Static electricity, something you vaguely remember from school, something unimportant. But what you're witnessing is the same force that holds your atoms together, the force that makes chemistry possible, the force that allows neurons to fire, muscles to contract, eyes to see. You're watching one of the four fundamental forces of nature act across distance, and we treat it like a novelty. That's the real problem. Electricity has become so familiar that we've forgotten how insane it actually is. What really happened? When you rubbed that plastic, electrons were transferred from your hands onto the surface. Only a tiny excess. Trillions, yes, but negligible compared to the total. And now comes the part that bends your intuition. Those extra electrons repel each other violently. The electromagnetic force between two electrons is unimaginably strong. Place them just 1 centimeter apart, and the repulsion between them is roughly 10 to the power of 42 times stronger than gravity. That's the one with 42 zeros. For electrons, gravity is meaningless. Electromagnetism dominates everything. So here's the obvious question. If electromagnetic forces are that powerful, why doesn't matter explode? Why doesn't everything tear itself apart? The answer is surprisingly elegant. Balance. Why matter holds together? An atom is a perfect stalemate. At its center are protons, carrying positive charge. Surrounding them are electrons, carrying negative charge. Like charges repel, opposites attract. In ordinary matter, positive and negative charges are mixed so precisely that their enormous forces cancel out almost perfectly. The forces don't disappear, they're just balanced, neutral, silent. And because those forces are so massive, even the smallest imbalance becomes noticeable. When you rub plastic, you move maybe 1 electron out of a trillion. That's practically nothing. Yet it's enough to make your arm hairs rise, because when the underlying forces are that strong, tiny excesses matter. You've never truly touched anything. Pick up a mug. What do you feel? You think you're feeling solid ceramic. You're not. What you're experiencing is electromagnetic repulsion. The electrons in your hand are pushing against the electrons in the mug with overwhelming force. They refuse to overlap. There is always a microscopic gap between the atoms in your hand and the atoms in the mug. Your hand never actually touches it. What you feel as contact is electrons pushing back across empty space, which leads to a disturbing realization. Every force you've ever felt, pressure, resistance, solidity, is electromagnetic. Every push, every pull, every sensation of touch. You have never physically touched anything in your entire life. Now consider wires. Imagine a copper wire running through your house. At one end, an outlet. At the other, a lamp. You flip the switch. The lamp turns on instantly. What happened? The common explanation compares electricity to water flowing through a pipe. Electrons enter one end of the wire and travel to the other. That explanation is wrong. Electrons drift extremely slowly, often about 1 millimeter per second. At that speed, it would take many minutes for an electron to cross your house. And yet the light responds immediately. So what's moving fast? Not electrons. The signal is. The wire is already filled with electrons. When you close the circuit, you create a voltage difference. That voltage pushes on electrons at one end. Because electrons repel each other, that push propagates instantly along the line, like a tightly packed crowd. You don't need someone to walk across it. A shove at one end is felt at the other. That disturbance travels through the wire at nearly the speed of light. That's what makes electricity useful. You push here, something responds there, almost instantly. Follow.